All right, so 5.4 is titled the remainder and factor theorems, and we're going to evaluate functions using what is called synthetic substitution. It is just like synthetic division, there's just a different way that we write our solutions. And we're also going to use the factor theorem to determine whether a given factor is a factor of a polynomial. So we can use synthetic division to evaluate polynomials for a given value, and we call that synthetic substitution. It's an alternative way to do direct substitution, but we interpret the answer differently, and that is what we are going to look at below. Okay, so we use this to evaluate the polynomials. Okay, and this is called synthetic substitution. All right, so the remainder theorem says if a polynomial function p of x is divided by x minus a, then the remainder r is p of a. So we're going to talk about what that means. Okay, so they talk about if a polynomial function p of x. So p of x is just a polynomial. Okay, p of x is a polynomial. So let's think about what it means when it says the remainder is p of a. So when you have a factor x minus a, remember we would set those equal to 0 and we would solve. Okay, so a is any number. If you have x is equal to a, if you're finding p of a, that is just the output value. Okay, that is the output value when you plug in a to the polynomial. Okay, so p of a is just your output when you're plugging in a. Okay, that's what you get at the end. So this is telling us that the remainder is equal to your output. So when you're dividing this, this is the same thing as evaluating the polynomial when x is equal to, so if it's x minus 3, x would be equal to 3. Okay, so they're saying you're dividing this, and then your answer is going to be the remainder. Okay, so here's our remainder. We would write this as p of 3 is equal to 7. So when you plug in 3, the result is going to be 7. Now we've been doing this with direct substitution. Okay, direct substitution is when you just plug that into the polynomial. So if x is 3, you would find p of 3. Okay, so when you find p of 3, you're plugging that into your polynomial. So this is x cubed, so we're going to do 3 cubed minus 4, 3 squared, plus 5 times 3 plus 1. Okay, so you can either use synthetic substitution, which is what we're going to learn how to do today, and another way you could find this is by direct substitution. So 3 cubed is 27. Follow your order of operations. So 3 squared is 9. 9 times 4, negative 36, plus 15 plus 1. Okay, so this would be 16. Negative 36 plus 16 would be negative 20. 27 minus 20 would give you 7. Okay, so this is an alternative way to do direct substitution. Your remainder is going to be the same as if you plugged it into the equation itself. Okay, so example 1 is asking you to use synthetic substitution. So I need to see that to find f of negative 2 and f of 4 for each function. All right, do we remember how to set up our synthetic substitution? So you have your coefficients, so x cubed, then the x squared, then the x, then the number. Okay, if we're doing f of -2, you're going to have -2 to the side here. And then you can go ahead and do your synthetic substitution. And we're going to do the same thing for f of 4. Okay, so I'll give you a minute to go through those. I want you to do them without your calculator. Okay, so when you multiply, you get -4, add straight down, multiply, add straight down. Okay, so remember, your remainder is going to be your final answer. The way you're going to write your answer is f of -2 is equal to 13. Okay, and then let's see how this one went. So 2 times 4 is 8. You get 13. 13 times 4, what'd you get? Good. And then when you subtract 1, you get 51. So I would do 50 times 4 and then 1 times 4. And that will give you 204, right? Okay, so 204 plus 7 is 211. So then you have f of 4 is equal to 211. Okay, this is function notation. Okay, so f of the input is equal to your output. Okay. All right, and then part B has the same direction. So we're still finding f of -2 and f of 4. Okay, but I want you guys to set up your coefficients. We can check that. Okay, so set up your coefficients. Here we're starting with x to the 4th, then x cubed, and then we don't have the x squared. So what do we got to make sure we put there? A 0. Got to have that placeholder. And we always drop that first one down. Okay, so we should have -12. Add to get -37. We're just doubling here. So just pay attention to your signs. This has to be positive. 37 plus 37 is 74. Okay, and then we just double 74. So you just have to double 70, which is what? 140. Double 4, which is 8. So this is -148. You add 3, you get -151. And then if you double 150, do you know what you get? 300, yep. And then so if you double 1, you get 2, so 302. Okay, so f of -2 is equal to 307. Now, when you set up the second one, you already know what the coefficients are. Okay, so 6 times 4 . 24. Negative 25 plus 24 is negative 1. I'll give you a second. Okay, so 4 times negative 1 is negative 4. Then you have negative 16. When you do negative 19, do you guys like doing the 10 times the 4 and the 9 times the 4? Oh yeah. 9 times 2 is 38. 38 and 38. Get negative 76. Okay, and then you are adding a positive 5 to this. So that makes it negative 71. Okay, so you have f of 4 is equal to negative 71. Okay, great. All right, now we're going to do an application with this, and we're going to have decimals, so you guys can have your calculator out for our next example here. Okay, so we're doing an application of synthetic substitution. Okay, the revenue from streaming music services in the U.S. from 2005 to 2016 can be modeled by this equation, where X is the number of years since 2005, and Y is the revenue in millions of U.S. dollars. Okay, what we have to do is estimate the revenue from the music services in 2010. Okay, so if it's in 2010, what is our value of X going to be in this case? Yes, how did we come up with that? Well, yeah, so it tells you it's since 2005, so from 05 to 10, 5 years. So when you set this up, I'm actually going to write my coefficients first because we have a lot here. So we're going to start with the x to the 5th, which is 0.26. Remember, if it's a negative, we want to make it negative. So negative 7.48 for x to the 4th, 79.20. Negative 3.33 for 81.68, and then 99.13. Okay, and we always drop that first one down. Okay, so like I said, we're going to use our calculator to do this, so I'm going to give you a moment to do your calculations, and then we will write our final answer together. Okay, so multiply across, add straight down. All right, let's see how it is. You can check yours along with mine. All right, and that should be our final. So when we write our final answer, it's going to be 211.78 millions per million. Okay, and then you can either just write the million next to it, or you can take that number and multiply by a million, and you can write that whole number out. Okay, so either way, that's fine. Okay, so you can put the million at the end here, or you can multiply by a million. Either one is great. All right, now we're going to apply this factor theorem, which tells us that the binomial of x minus a is a factor of the polynomial p of x if and only if p of a equals 0. So when they say that p of a equals 0, they're talking about the remainder. Okay, so this is the remainder equals 0. When you perform synthetic division. Okay, that means that this factor goes into your polynomial evenly. Okay, there's no remainder. The remainder is 0. Okay, and just like we did before, we have to remember the leading coefficient of our divisor has to be 1. If it's not, that's when you can divide. You have to divide by the leading coefficient. Okay, so for an example, they'll give you like x plus 6, and then they'll give you a polynomial x cubed minus x squared minus 30x plus 72. Okay, so if you perform synthetic division, okay, then x plus 6 is going to be a factor of the polynomial if the remainder is 0. So if we're going to do synthetic division, we would take x plus 6, set it equal to 0. Okay, we're going to set up our synthetic division here. Okay, so if they asked you, is x plus 6 a factor of the polynomial, you could perform synthetic division. So multiply, add straight down. 42 minus 30 will be 12. You get negative 72. Yay. Okay, so if the remainder is 0, what that means is x plus 6 is a factor of the polynomial. So factors go into values evenly. Okay, so factors of 12 are 1, 2, 3, 4, 6, 12, because they all go in there evenly. Polynomials also have factors. Okay, and they are expressions. So example 3 says, given a polynomial and one of its factors, find the remaining factors of the polynomial. So they're going to give you one factor, you have to find the rest. Okay, so for A, they give you x cubed minus 3x plus 2, and one of the factors is x plus 2. Okay, so they give you a polynomial and then one of the factors. So we're going to do synthetic substitution, synthetic division. This is our divisor. So if I set it equal to 0, I know my x value is negative 2. Okay, go ahead and set up your coefficients. Okay, so we're starting with x cubed. Remember, there's no x squared, so we got to put 0 in there. Don't forget that. Gonna multiply, add straight down, multiply, add straight down. Yay. Okay, so this is a factor. We already knew that. What we have to do is find the other factors. So remember, this is the constant term, the x and the x squared. What you have is a quadratic trinomial that you can factor. Oops, sorry, we are going to do the equal 0 because you don't have to solve. Okay, so what we're going to do now is factor. Okay, so if I factor this, I'm looking for two numbers that multiply to that multiply to positive 1 but add to negative 2. What are they? Negative 1. Yep. Yes. So once you divide, it is going to bring that down. So this is going to be your remainder, your number, the coefficient of x, the coefficient of x squared. And that should always happen when you're dividing, when you're using synthetic division. No, because we aren't solving. We're only looking at the factors. So these are your remaining factors, x minus 1 and x minus 1, or you can write it as x minus 1 squared. Okay, these are your remaining factors. Yeah, so I wanted to solve because that's something that we do commonly, but this is just asking for the factors, and you can write it in either one of those ways. Okay, and then for B, we have 3x cubed plus 4x squared minus 5x minus 2. And then the divisor is 3x plus 1. So if you're using synthetic division, remember the leading coefficient has to be 1. So 1. Yeah, it has to be 1 for the divisor. So the divisor has a coefficient of 3, which means we're going to have to divide everything by 3. Yep. Okay, so Alco has to be 1. Okay, so we're just going to divide everything by 3 here and here. Okay, so here you have x plus 1/3. We do set that equal to 0 so that we can find our value of x that we're using for synthetic division. And then when you're setting up your synthetic division, you can just write the coefficients straight from your division, because 3 divided by 3 will be 1. And then 4 divided by 3, you're going to keep it as 4/3. Negative 5 divided by 3, negative 5/3. And then negative 2 divided by 3 is negative 2/3. Okay, and then your x value is negative 1/3. We always drop the first one down. Okay, so in order to use synthetic division, you have to have this coefficient be 1. And if you divide this by 3, you have to divide the polynomial by 3. So anything times 1 is itself. This is actually pretty nice because, yeah, you're just going to get 1. You have 3 over 3. 3 over 3 is 1. And you already have your common denominator. Okay, so here you have negative 1/3. So that would be negative 6 over 3. What does that reduce to? Negative 2, yeah. Because you'd have negative 6 divided by 3, which is negative 2. And then here, when you multiply by the top. A negative times a negative is a positive. Okay, and then with this, you should always get 0 because they're telling you that this is one of the factors. The reason why we're using this is so that we can take this trinomial and we can find the other factors by factoring. Okay, if it's unfactorable, then this would be your final answer. Okay, but we're looking for two numbers that multiply to -2, which means one has to be a positive and one has to be a negative, and then they add up to 1. So what multiplies to -2 but adds to 1? Plus 2 minus 5. Good. Okay, so these are your remaining factors. So that would just be your answer. Yep. Now, if you wanted to check, you could always multiply these two together. You should get this. And then if you multiply this by the 3x plus 1, you should get your original. Okay, so we're just factoring those large polynomials. Okay. All right, and then I'm going to write down your assignment from 5-4. Okay, so there's a couple sets of these where they're just the evens. So the 6 through 12 are evens. Number 21, there are multiple parts. Can you just quiet for right now? For 21, there are multiple parts. You only have to do A. Okay, so don't do any other parts besides A. Okay, and then 24 through 34, just the evens. (24 through 30 are the evens.